Today is lesson 7.4, applying percents and fractions. In the first example, it says that the circle graph below shows the results of a survey of how 500 students prefer to spend time. So we need to know the percent of students, what percent of students prefer to spend their time with friends. And if you look at the circle graph, remember that each part of it, if it's in color, might be a different color, is usually given as a whole number, or a fraction, or a percent, the data on the graph. And this one's a whole number. And since you're given that the total number of students is 500, the number that associates with the students that like to spend time with friends is 40. So the fraction becomes 40 over 500. So first you have to take the information given and write it as a fraction. It is 40 out of 500 students that prefer to spend time with friends. That fraction we found from yesterday's homework could be a decimal, it could be a percentage, and so that's what we need is the percentage. So remember, we could set up the proportion, and when you cross multiply you get 500p is equal to 4,000. When you divide both sides by 500, you will get your percentage. So in this case, 8%. 8% of the students prefer to spend time with friends. Note also that on the circle graphs, the section given to that represents 8% of the total degrees in a circle. So there's 360 degrees in a circle. The size of that is relative to the percentage. So 8% of 360 tells you the number of degrees that is that section of the circle, and there's 8% that prefer to spend time with friends. Okay, in the next example we're going to look at languages. So the circle graph in this one shows world languages that U.S. high school students studied in a recent year. Each fraction in the graph represents part of the total number of U.S. high school students who studied world languages. So you can see that we have 9/50ths studied French, 2/25ths studied other, 1/20th studied German, and 69 out of 100 studied Spanish. We're not told how many students were surveyed in this one, but it's relating it to a fraction, which is then also a percentage. Remember that it is also a percentage of the circle. So which language was the most popular? We would simply look at the biggest piece of the circle, right? Which one covers the most area? And it's obviously the Spanish. So we would write Spanish for A. If it becomes to where they're too close, you might actually have to figure them out numerically or percentage-wise. So what percentage of the students studied German? In part B, we know that the fraction is 1/20th, and if we wanted to change that to a percent, right, we have a percent proportion that would be equivalent. So we would have 20p is equal to 100. So p is equal to 5%. What percentage of the students studied French and German? Well, half of our work is done because we just found how many students studied German. So we need to know how many students studied French. That proportion is 50p equals 900 for the cross products. So the percentage that studied French is going to be 18%, so 5% German, 18% French, and I'm going to continue this problem down here. So we would add those together. 5% plus 18%, we get 23% to answer C for the percent of students who studied French and German. Another way to do that would be to add the fractions together if you wanted to get common denominators and do that, but chances are you'd probably just as soon add the percents together. And then we want to know the percent of the students that did not study Spanish. couple ways to do this. What's the percentage of the students that did study Spanish? You could look at the fraction. Since it's over 100, we know that relates to 69%. If you subtract that from 100%, because 100% is the whole circle and all the students, regardless of the number of students, you could get it that way. Or you know German, you know French. If we could calculate the percentage of other, we could add that in to the 23% and get that total. So let's do it that way. So if we're calculating other, we have 25p equals 200. So other is 8%. So we have 23 from French and German plus our 8% equals 31%. Another way that I told you is to look at Spanish and take that from 100%. Okay, and you get the same answer. So when you look at this next example, we have a graph about pie preferences, which shows the data in percentages. So our first example was whole numbers, then we did fractions, now we have percentages. So now we have to try to answer some of the same questions. How many people chose cherry? The question or the example tells us that the graph shows the results of 300 students. So we know that 300 students, that's the total number of students, which relates to 100% of the graph. If we added up all the number of students that liked cherry or pumpkin or pecan or coconut cream or apple, that number would equal 300, okay? So now we are taking 23% and converting that to the number of people. So we have a proportion that looks like we have the percentage, so 23 over 100 represents cherry, equals x over 300. And the reason I chose to put the number of students in the denominator is because that's the total number of students, the whole that we're talking about. And remember that the ratio is always part to whole. So when we cross multiply, we're going to get 100x equals 6,900. And when you divide both sides by 100, x will equal 69 students that like cherry. So 23% equals 69 students. Okay. Looking at B, how many people chose, and here I am thinking that it's students again, it's just people. Maybe they aren't students, but that's okay. How many people chose apple? We have 36%. So 36% of 300 is what we're being asked. So 36 over 100 is the percent ratio. The part out of 300 that like apple are represented by this proportion, and we can cross multiply to get this equation. When we divide both sides by 100, we get the number of people, or that like apple as 108. These people are just people, not students. Okay. Now we're being asked how many people chose either pecan or coconut. Okay. Here's your pecan is 8%, coconut is 3%. When I look at that, I'm combining those two pieces of the pie, and it's just as easy for me to combine those percentages and do one calculation. So if I calculate 11% of the total, I will get the combined total. Does that make sense to everybody to be able to do that? To take 8% plus 3% equals 11%, and that would represent the two groups of people that liked pecan or coconut. So if I do the proportion with 11, x over 300 to get the cross product of 100 x equals 3,300. I get 33 people that liked either coconut or pecan. And then how many more people chose the pumpkin than the cherry? Well, we know the cherry, so we have to calculate the pumpkin, which is 30%. So 30 over 100 equals x over 300. 100x equals 9,000. And if the number of people that like pumpkin is 90, to answer this question, we would subtract that from 108. When you take, oops, wrong one, that's apple. Let's do it from the number of people that like cherry, as the question asked, which is, well, let's just do it completely different then. Let's take 90 minus the 69, because when we want the difference, we want it to be a positive difference. And we get 21. And when we look at these numbers, we're going to order them from least to greatest. I know we've had a little bit of experience doing this year. The first thing I'm going to recommend is that you change everything to a decimal. So, the first one is a decimal. If you take 9 and divide by 40, you could change this to, well, let's get a marking pen here, 225 thousandths. 22% becomes 22 hundredths. The next one is a decimal, and the last one, when you take 28 divided by 125, you get 224 thousandths. So then, if you want to use graph paper, you can, because the key is to line up the decimal points for each one of these, so we can look at each place value. The other key is to write your answer in the original form. So, looking down, we're going least to greatest. When I look down the first, in the 10th place, the first one is a 0, which has to be the smallest. So I go ahead and write that, and that was the original form of that number, 0.022. The next one I look at, they're all 2, so I have to go to the second column. They're all 2, so I have to go to the third column. Since there's not a number here, I fill it in with 0. Since 0 is the smallest number, my third number over, so 22% is the next largest number. So I've gotten rid of this one. I've gotten rid of this one. Okay. Now basically it's 4, 5, then 8. So it's the last number, the 28 over 125. The second number, the 9 over the 40. And finally the decimal, 0.228. And again, we're putting them back in the original form. So this becomes our answer. I don't want to see your answers in all decimal form. Okay, for the next example, writing it as a decimal, we're moving it to the left 2 places, so 0.066. 3 divided by 50 is 6 hundredths. 0.6% is 6 thousandths, and the rest are all decimals. So going left to right, I'll put them in order. Okay, looking down the first column, there's a lot of zeros and a 6. So right now I already know that this last one is my largest number, so it's going to keep its place here at the end because we're going least to greatest. So let's figure out the rest. The one that is 0.6% right here, looking at the second column, has a 0. So that becomes the smallest number, so I write it in its original form. Then when I look at the other 6s, I have to look at the third column. These two have a 0, and since basically in the fourth column this would also be a 0, the second number, 3/50, becomes my next in line. Okay. Then I have the 0.0606, then the first one, 6.6%, and finally we said that 0.606 was the last one in order. Sorry, I ran out of room there.